Hello, this is János, it's Revered Audio, and this video is for Ivan about modifying the Heathkit W1 or W2 for taking higher B plus supply, running at higher voltages. What else do we need to modify in the original circuitry, and what else to look for? And this video I think is also applicable if you are looking at other similar topology push-pull amplifiers. You will see what I'm going to talk about. So in the case of the Heathkit W2, you see that this is the amplifier schematic, so it doesn't show the B plus supply. So now I'm just talking about the amp part, and on the bottom, this like 4 3 2 1 there, this is the input. So this is where the amplifier chassis gets the voltage from the other chassis, which is the B plus supply and the filament voltage supply. So it's supplied by an umbilical cord and the number 4 wire and number 3. So number 3 is ground, number 4 is B plus, and 1 and 2, those are the filaments wires, and then all 4 tubes the filaments are connected together in series. So on this side of the schematic, it shows the input from the umbilical cord, and as you see, it has also these numbers on the other side, which might confuse people, but this is the output for a preamplifier, because you can attach a preamplifier, a Heathkit preamp, to the Heathkit amp, and that uses the power supply of the W2 or W1 to supply the preamp both with heater power and high voltage, B plus voltage. So in our case, we are disregarding the preamp out because we are not going to put preamplifier, but if you want to, you can, that's your choice, but it's not needed for now. And just be cautious that this is not where you connect the high voltage, you connect it here on the umbilical input side. I think this is just something just for starters. So this is what I've shown in my previous video, the schematics for the original Heathkit, and I mentioned the W2 version, and I mentioned that the 5881s I used, instead of these tubes, I used 807s. So now I'm going to show the schematics for that. If it would advance, yes, it advanced. So now actually what I'm showing now is the schematics for the Heathkit W1, which is almost the same as the W2, just using 807 tubes. And the other difference is it also has this is the feedback loop, and it has a little different feedback. It has higher feedback which means a lower feedback resistor, creating a higher feedback compared to the 5881. So as you see, that was one thing that they did, that for the newer Heathkit they took the feedback a little bit down compared to the 807. However, there are several things still in question, and one of that is that in the Heathkit W1, the supply voltage that we get here at the pin number 4, I think that's about 410 volts or something like that. So, and what I did, because I didn't know what was the original supply voltage here, that I built it 20 years ago with 475 volts as the source for the B plus, and it worked perfectly. However, there's certain things that you must observe if you increase the plate voltage. I mean, as a side effect, the plate voltages will increase on all of the tubes, but And the 6S and 7 is actually an extremely rugged tube and can handle monstrously high plate voltages. You can even run them with 300-400 volts on the plate, and in the schematics they are run below 200 volts on the plate, so don't worry about that. What you need to worry is the wattage of the resistors, which if you put higher current on them, higher voltage, higher means higher current as well, and the 2 watt values will be insufficient and not as stable, so you might want to oversize that. We will get into that soon. However, the most important is that the 807 tube, while it can handle exceedingly high plate voltages, you can stably operate an 807 even with 800 volts on the plate, but the screen, this is the connection number 2, it must not see higher than 300 volts on the screen. And what you can do with that is that most people would say here nothing. You cannot run it in triode mode unless you max it out at 300 volts. And then, however, they've done a lot more research and experimentation with the 807 tubes, and there's the STC tube datasheet that I found, which is the most extensive tube datasheet that I have known that has been generated for any vacuum tube, and it's about 30 or 40 pages long. Is just an absolute incredibility. It's a manual. So for those of you who know about tube datasheets, they're usually 1 or 2 pages long, and some go as far as 3 or 4 pages, but that's really rare. And in the case of this tube, there was so much application data gained from its massive, absolutely massive use in telecommunication, that they generated 30-40 pages just as the basic information for this tube. And what I found in this datasheet is that it says that you can run it in triode mode with way higher voltages than 300 volts on the plate. Just this voltage that connects the screen to the plate, you need to increase it drastically. And the STC datasheet recommends 10 kilo ohms per 100 volt beyond 300 volt, that for stability and longevity. And what I did is that in my Heathkit I used a 2 kilo ohm resistor, so I tied it with a 2 kilo ohm resistor to the plate, and I used a 3 watt resistor there. So here you just have to be sure that you use a substantially high wattage resistor to tie the screen to the plate, for the reason that with the AC signal, with the fluctuations that you see, it might see very high voltages and very high voltage fluctuations, and the resistors, when you have a very low wattage resistor, they don't have high voltage tolerance and they will burn out. And actually in this operation, not in my Heath, but in my Ampex that I currently have, I did burn out the resistors here. So it's not just something that oh, you know, people say and it never happens. It does happen. So in my Ampex, where it's running almost the same topology, at least the power tubes I run in the same configuration, and there I have 560 volts on the plate, and I had 2.7 kilo ohm resistance there, and 2 resistors in series, a total of 4 watts, and even that wasn't enough. It arced through and burned through, and the amplifier is not happy after that. And interestingly, the tubes were not damaged, so it still was enough to protect the tube, but it did buzz the amp, and I could see that the resistors were burned out, so I replaced them and I added substantially higher resistance to that. But just be mindful that with the recommendation of the manual, they recommend 10 times higher value, like 25 kilo ohm in the case of 550 volts. I was using much less because for many years it was fine, but apparently, even if you, like in my case, I'm running my amps, it's on like at 6 to 8 hours a day and every day, so that's how much usage it got. And I noticed this happening after several years, 3 years or so. So that's incredibly high number of hours. And even then, actually it happened when I haven't used the amp for half a year or so, and then when I turned on, it wasn't happy. So that's about it. I think that was a really long-winded story, but to emphasize that here you need something much higher wattage than necessary. And now I'm just going to the next page. So now I'm showing actual values, and here I give you like a range of voltages from 475 volts to 550 volts supply voltage for the B plus, and actually so in my case I used 475, but I would say you could go as high as 550 volts. Higher than that, I recommend it only in two cases. One, that you don't use an umbilical for that, you build it into a single chassis. I would not trust running a cord with 600 volts running through it. It's just too risky, I think. And what else? For 600 volts also, that's 600 volt is just super dangerous. So if you are not used to it, then just don't. If also, even if you are used to 400 volts, 450 volts, something like a stereo 70, like a Dynaco stereo 70, even in that case going for 500 volts, that's a major jump in risk. And what an electrocution does to you in case you get yourself zapped with it. If 450 volts zaps you, that's pretty darn bad. But if 500 volts zaps you, that's 10 times worse. Yes, the difference doesn't sound much, it's just 50 volts more, but it feels 10 times worse. So that's why I would caution everyone, if you are planning to up the voltage you are working with, never ever just jump voltages significantly. Always choose a project which is just like 10% or maybe 15% higher than what you are used to in this range when you are getting close to 500 volts. And do not do sudden changes, like you are comfortable working with 450 volts and then you go for 600 volts. Don't do that, you will kill yourself. Don't. Just make sure, just go baby steps, because with each small increase in voltages beyond 400 volts, the risks and hazards exponentially increase, and you must take your time learning and adapting to working with higher and higher voltages, and and you need just exponentially more experience working with circuits, and you need to have safety and practices absolutely ingrained if you want to go anywhere close to 500 volts. So above 400 volts you must be really cautious of that. So that's why I really want to just super emphasize that don't even though I share with you that the 807 tube likes higher and higher voltages, but do not just mindlessly go for very high voltage, because if you are not ready for that yet, then you will have two results only: killing yourself and burning your house down, and you don't want either of that. So that's my extremely dire warning. Also, one more warning is that the 807 tubes, they love, so this is the range that it loves, 475 volts, that's where it starts to wake up, and up to 550 volt. That's what it really loves. And when you increase the B plus to 600 volt, it doesn't sound good at 600 volt. I didn't like it. Or what you could do is you need a very different load, very different output transformer. But then these transformers that these Heath W1 W2 have, or the Ampex amplifiers using 807 tubes, all of these vintage gear with these peerless transformers, they are not suitable for 600 to 650 volt supplies. So that 650 B plus range, that will give not good sound. So you, with these transformers, you either stick to this range, this voltage range, supply voltage range that I show, or go to 700 to 800 volt range, maybe even 820 volt. That was the most that I ever tried, but I didn't feel safe with 820 volt, so I made a compromise, and currently I'm using in my set amplifier 760 volts. But that requires yet another level of awareness and experience with handling gear, and if you do not have 3 multimeters, then don't go there, because in that 700 voltage range, 700 volt range, you need at least 3 meters, because you have to connect your meters before you turn your amp on. There's no poking around in the chassis, because that's going to guaranteed that you will get killed with 700 volt, even if the probe not touching like just a quarter inch next to the wire, it will arc through that already. So it's no joke. This is where really bad things start to happen. 475 volt, 500 volt is not that range yet, but it's still absolutely no joke, especially if you build your power supply with film capacitors. When you use the DCLink capacitors, I use DCLink capacitors. These are film capacitors that have virtually no internal resistance, virtually no internal inductance, and they are capable to release charge immediately, and they just zap you a lot worse compared to electrolytic capacitors. So that's why you have to be extremely cautious even with 475 volts. And if you want to work on these tube amps and tube amps in general, just make it general practice to bleed all the voltages before you start poking around in the chassis when you power it off and you work on it to do things. Just always make sure, even before you start poking around, first measure with your multimeter the high voltage, measure it like 5 times, just in case maybe if you sometimes if you don't touch your probe, your meter properly, then you might think that there's no voltage in there, your multimeter shows nothing, but then you just need to move the probe a bit and oops, I have 500 volts in there. So it happened to me so many times that with the meter I measured, oh, there's no voltage there, nothing, and I start working on it and huge zapping sound and flash, like searing white light, and then the smell of burned plasma, and then part of my screwdriver missing that just got turned into plasma by me discharging the either DCLink cap or an oil filled cap. The old oil field capacitors can also just discharge extremely fast. And the bad thing with oil field capacitors is that they recharge. So once you drain the power supply, they have memories and they will build up a partial charge. So if you work with oil field capacitors in your power supply, you must hook on bleeder resistors and keep them there to prevent the old caps gaining back their memory. Once that's how I turned part of my screwdriver into plasma, that I have discharged the oil cap in my power supply. It had 450 volts there, and I drained it to 0 and then waited half an hour, and then just before working on it, I just shorted the 2 leads of the oil cap with my screwdriver, and then bang, it was like a lightning. It was as bright light as lightning and like thunder, deafening, and then part of my screwdriver missing where it touched the lead. So this is no joke, and that was the screwdriver. It could have been my hand and my life. So really I'm telling you these stories because just to ingrain that how dangerous it is, and this is something that I had to learn compared to working on things like the Dynaco Stereo 70 or my Darling amplifier, which go up to 450 volts DC. And you might say this is not much more than that, but yes, it's a lot more. Anyway, so here we are. I'm showing you now my recommendations for the values, and where shall we start? So let's start with where I ended on the previous page, which is these resistors on that tie the screen to the plate of the output tube, the 807 tube. And I made the colors like red that correspond to the 407. So if you have 475 volt as your B plus, then I recommend at least a 6 kilo ohm resistor, which is at least 3 watts. You can also use maybe like 2 watt resistors, but then use 2-3 kilo ohm ones in series. But even in that case, I would just recommend 3 watt 3 kilo ohm resistors in series for safety. And if you go for 550 volts DC, then I recommend at least a 10 kilo ohm resistor, at least 3 watt, or you can also split it into 5k plus 5k, 2 5 kilo ohm resistors, each of them 3 watt in series, and that will be working there very solidly. If you use smaller resistors there, 2 things will happen. One, your your amplifier might just fail at one of the startups, and number 2, it will age the tube, the power tube. So it will lead to premature tube aging. So that's why it's really important. That's why I gave it a different color. Now there's another red blue thing here. This is a resistor that was not there in the original schematics. So after you get the high voltage and it feeds the output stage, then you go and you feed your driver stage, phase splitter and input stage. But in the original schematic, you fed it directly with the same voltage that the power tubes were receiving. Here, if you are using 475 volts, I would just recommend placing a 12 kilo ohm resistor just to drop a little bit of voltage at 3 watts rating. If you run 550 volts DC, then put in a 25 kilo ohm resistor, 6 watt rated. And then that will supply all of these tubes, the 2 6 and 7s. And then for those 6s and 7s, there's like two bypass capacitors. The original design asked for 20 microfarad at 450 volts for both stages. What I recommend is go for 50 microfarad and 600 volt rated, and I would say always like rate these as high as the potential B plus input is, and here I would recommend also to use those Kemet DCLink caps, or you can use Panasonic DCLink as well, and those are film capacitors. You can use other brand film capacitors as well, or Mundorf or whatnot, but that will be possibly a lot more expensive, very pricey endeavor. Good sound though, but you don't have to pay a king's ransom. You can use Kemet DCLink. Those are Swedish capacitors, and it sounds exactly as a Mundorf Evo oil. You can't tell the sound between the two of them. They have the same sonic signature. And what else? So I think now we started out now with the supply. So here so we added one resistor from 12k to 25k depending on the B plus you are feeding it, and then after that just keep the same value drop resistors for these stages, 22k, 33k, but I would increase the wattage. It shows here 2 watt. I would up it to 3 watts for operational safety, and 33k I would use something like 4 or 5 watt rated. Probably 3 watt would be enough, but just in case, just go higher, it won't hurt. And then now let's look at the input stage. Now we are done with the power supply part, so let's look at the signal part, at the amplification chain. So here they have a capacitor in front of the input tube. This is just to decouple the inputs, so if just in case there was some mess up and some DC coming in, that capacitor blocks the DC. Nowadays we don't have defects with the preamps like that anymore, so that's nowadays like an unnecessary safety feature. Although I have to add that sometimes if you put a capacitor in front of your input tube, it can happen. Sometimes if you have like picking up some noises through your interconnect, picking up EMI or RFI, sometimes if you have a capacitor in there, that can help. And peculiarly, even though a capacitor in itself is worse sound than no capacitor, but if you have some kind of RFI EMI pickup through your interconnect and you put a capacitor there, it will make it sound better. It will sound more relaxed, more natural. And then in the original design there is a 470k input resistor there. Then that's the, and you can make it smaller. You can make it like you can even put like 100k pot in there, and then that's your volume control for your amplifier. And then that's it. You don't even need a preamp. You have the volume control built in there. Or you can just put in a 100k to a 200k resistor just to fix it there. Now if you put a lower resistor there than 470k, then you need to increase the input capacitor size. So if you half it, and let's say 220k, then you double the capacitor to 0.1 microfarad. And if you drop it to 100k, then it's 0.2 microfarad. And I would say you can go even larger than that, like up to like 1 microfarad, just to experiment. However, there is also something I talk about that later, not here. Other thing, now the cathode resistor for the input tube, it's originally a 470 ohm resistor. They did not specify the wattage. I would recommend put here a 560 or 570 ohm. I think 560. There's no 570s. 560 ohm 2 watt resistor. If you put a 610, that's fine too, don't worry. I would just put a tiny bit bigger than the 470, rated at 2 watts. And then for the load for that tube, just keep it the same, 47K and at 3-4 watts. And then now we are going to the phase splitter. So phase splitter had 22K at the cathode, 22K on the plate, and I would just increase it to 27K, 5 watt each. And then the signal is going through originally through a 0.05 microfarad capacitor, and if you are keeping the feedback as is, then keep these capacitor values as they are. If we are to decrease the feedback, then we can increase the capacitor values. So let's go, maybe let's just move it to somewhere else so you can see. So now you can see here what I'm listing here. So originally the W2 circuit has a 6.8K feedback resistor here, bypassed by a 47 picofarad capacitor, and the W1 or WA1 has a 3.3K resistor but no capacitor across. This is not as stable, and I would recommend to use that 6.8K bypassed by a 47 picofarad capacitor, and then you can increase this to even up to 0.2 microfarad and use the good high quality coupling capacitor, film coupling capacitor there. Same thing for the other part, for driving the other part of the push-pull pair, 0.2 microfarad. Now you can go try and decrease the feedback loop further, such as go for like 20K plus 16 picofarad, or even better 50K plus 10 picofarad. And in that case you can go even higher, like 0.6 microfarad for this capacitor. The reason for that is that when you have a smaller microfarad capacitance here, that limits the low frequencies that can be passed through that capacitor, and that it needs to be limited to keep the feedback loop stable. And if we are decreasing the feedback loop, then we can put a larger capacitor there, and it still will not destabilize the feedback loop. However, it's up to you. Try out. Probably a 0.2 microfarad capacitor will be sufficient here, even if you decrease the feedback loop significantly by going to the 50K 10PF version, or you can completely omit the feedback loop, and if your loudspeaker and the rest of your system is on point, then the no feedback version will give you the most intricate, most humane, most natural, most I would say what people would say musical or magical sound. But if your rest of the system is not ready for yet, then you might need some feedback for most satisfactory sound. And that amount of feedback is also an indication like how's the rest of your system doing. And of course you can grow in any direction you want, but the ability to run without feedback will be a surefire way to tell you that you are growing towards a system implementation that allows to get more of the interpretation of the music. And when you are using the feedback and high feedback, then this amplifier will be absolutely phenomenal with rock music and pop music, music recorded in the 70s, but it won't get you as much with classical music, baroque music, large orchestra. It will still be quite smashing even with that, really powerful, very dynamic, large scale, but you won't have those nuances that you would get, let's say, with a 2A3 or a 300B amplifier on the mid-range, or like fine tone changes in the violin, or fine layers of interpretation. And as you decrease the global feedback, you will access that more and more. But if the rest of your system is not ready for that, then the power delivery will fall apart, and you will feel as if the bass is disappearing. So now let's go back to these resistors here. So here there are the input resistors for the 6S and 7 drivers are originally 470K. I would say decrease it tiny bit to 330K, and that also has the same effect as if you are decreasing the size of your coupling capacitor. So if you have, let's say, 0.2 microfarad 470K, that is equivalent to having 0.3 microfarad capacitor with 330K, something like that. So just keep in mind that by lowering that resistor, you need to up the capacitance for the coupling cap. But for the coupling cap, the quality of the coupling cap is a lot more important than the actual value. So if you can get even like a 0.1 microfarad very high quality film capacitor, go for that rather than going for a half microfarad or even a 1 microfarad but lower grade capacitor. It will give you a much more satisfactory sound. And here this resistor doesn't have to be high wattage, even a half a watt is plenty, because there's not going to be any current drawing through this. And I would recommend dropping this a little bit, because especially here in this driver duty, when you are pushing the 6S and 7, as you go higher and higher in the output, in the dynamic range, you are getting closer and closer to so that it needs more and more grid current to be drawn through that resistor, and that 330 is a lot more gentle on the tube than 470K. 470K is like the absolute limit, and you don't want to run a tube in this heavy duty close to its absolute limit at its grid resistor, grid bias resistor. So go for 330K, or maybe you can even drop to 270 or 200K. And here now, cathode resistor. Now it has a common cathode. You can even like split it to separate, but if you keep it as a common cathode, instead of the 390, I would go for like a 510. If it's a 475 volt B plus, or keep it maybe 570, 510, 570. I would say experiment with it. I gave it like 5 watt rated resistor, 570 ohm, and try it out as a starter with this and see if you can decrease it, measure the voltages, measure what is the current that these tubes are biased at, and if you are not exceeding 50% plate dissipation, then you can go even lower for this resistor value to give more apparent power to your amplifier if you need it. But I would say just keep it at 570, and this will ensure that this tube here will have an extremely long life. And And for its load resistor, instead of the 47k 2 watt, I would recommend a little bit higher, 56k, and just up the wattage 4 watts. And when you have higher wattage resistor, the effect will be a more relaxed, more lush sound. And when you are listening to more dynamic music, it means that more voltage fluctuation, higher current is running through those resistors. They are heating up more, and the smaller the resistor is in wattage, the more it is affected by thermal effects. And if you put like a higher wattage resistor there, then it is going to be thermally stable even when you push the amplifier to its limits, which means that thermal stability means that with temperature changes, every resistor changes resistance value. And if you have a higher wattage resistor, it is a lot more stable. It changes value a lot less based on the material you are running it. And this is also true for this half watt rated 330k resistor. You can put there like a 2 watt rated resistor for extreme thermal stability, and you will be rewarded by it because this resistor has a very high impact on the sound. However, if you put there a 2 watt resistor, it will take ages to break in, and you just need to be waiting for about a year for your amplifier to truly break in, and most people just don't have that sort of patience. So that's why I just put like a half a watt resistor there. But if you are the patient kind, put on a 2 watt resistor, it will be good. Now what else? So this 50k 4 watt for one of the plates of the drivers, and this is for the other pair of the push-pull driver. Same thing, 56k 4 watt. And then output capacitor for the drivers, or originally it was quarter microfarad, 0.25 microfarad. I would recommend like 0.25 to 1 microfarad depending on your feedback loop. What are you doing? If you're keeping the original, keep it 0.25. If you are decreasing it, you can go higher, but go higher only if you have a very high quality coupling capacitor, and if price is your consideration, then rather choose a 0.25 microfarad very high capacity coupling cap than a 1 microfarad lower capacity cap. Even though it's 0.25 microfarad, if it's a nice high capacity coupling cap, you will have better bass than with a lower quality 1 microfarad cap. And I would say just keep that 1k grid stop resistor, and then the reason for that is that the 807 also operates into the high megahertz range, and that 1 kilo ohm resistor is needed there to make sure that the tube will not start working as a telegraph tube in the megahertz range. You want to limit it to the audible range. Just keep a 1k resistor there. You can also get by using like a 200-300 ohm resistor, but just today that we have more and more RFI EMI pollution, just use the 1k resistor. Just use a very high quality resistor. I would recommend like a Coache pair carbon film resistor. It doesn't need to be high wattage. 1 watt is plenty, and it won't be subject to any kind of thermal expansion, so 1 watt is plenty. Now keep these resistors 100k, so these will be for the 807, the grid bias resistor, the grid bias resistors. However, we are going to change this thing here. So as you see in the original amplifier, what's the time? 44 minutes. Okay, we have this scheme, so they are common biased, so there's a common cathode resistor. This thing here shows this is where you can measure it. So these are the measuring terminals, so you can put probes there, one end of your meter to this spot, another end of your meter to the other spot, and then you can adjust this pot, and when you read 0 between those two spots, that's when you get like a perfect balance between the two. That's how you can balance them out. And your question would be like, how come, what's happening there? Because this, you see, there's 100k and that's only 100 ohm. What on earth is going here? So this thing here, this voltage splitting there, and there's a pot there going to ground. So this is where, from the viper of that 100 ohm pot, this is where the cathodes of the 807s go to ground. So this is where the circuit terminates. And what is happening here is that this 100 ohm pot there acts as a voltage divider for a part of the cathode bias voltage and feeds it into the grid bias. So basically this tube is like a 95% fixed bias, 95% self bias with a 5 to 10% or 0 to 10% fixed bias. So it is a hybrid self bias fixed bias mechanism, which is largely self-biasing, but it's using a part of that self-biasing voltage through this very simple and ingenious divider network to also give a few volts plus or minus to the as a fixed bias for the tube. And now, in my experience, when I redid my Heathkit, I just omitted this completely, and you don't need it at all. So let's just go to the next slide. So just take that at all, that I took it out completely, and so what I did is that it's just connected to ground. There's no pot in there. The 100k input resistor, I mean grid resistor, and this grid resistor, they go to the ground directly, and there is a cathode bias resistor separate for each tube, each 807, and instead of 100 ohm, it's 1.2 kilo ohm 5 watt rated for each 807 tube. And what I really recommend for you to try is bypass each of them separately with a small electrolytic capacitor, a 22 to 47 microfarad 63 volt rated Elna Silmic 2. And now I know there's a lot of people who don't like bypassing the cathodes, because that gives problems. What I've noticed is that when you bypass it with low quality capacitor, that gives problems. And under low quality capacitors, I also add specialty capacitors like the Nichicon Muse, which is absolute junk, 2 thumbs down, or any kind of Nichicon, just forget it. It should be banned. Nichicon should be banned from any and every single audio product. They are absolutely noisy, really. It is just horror what they do to the sound. Change your Nichicon to an Elna Silmic 2 and you will have a jaw drop. It's just absolutely night and day. So basically you can put a cap there, but I would say try it without bypass cap and try it with the Elna, let it break in for a little while, and just go with the solution that you like more. If you are not using the original chassis, you are doing a complete rebuild, you can put here a Kemet DCLink film capacitor, and that's even better than the Elna. What else do we have here? For finishing touches, for the filament supply, I do recommend that you, even if you have like a transformer for the B plus supply, which you are rectifying for the high voltage, and it has a filament winding in it, just get a separate filament transformer, which is like a 5 to 6 amp rated 6.3 volt filament transformer, and use that separate filament transformer to drive to heat the filaments, and that will be you will be massively rewarded for that. One extra thing that you will gain with that is that put different switches for your B plus and for your filament, and then you can turn on first your filaments, all your tubes warm up, and when your tubes are warmed, then turn on the main transformer, which turns on the B plus, and when you have your all tubes cozy and warmed up, and then they are receiving the high voltage, it is very easy on the tubes, and you will have massive benefits for tube life and longevity for doing that, versus the case that the high voltage is starting to hit the tubes before the filaments have warmed up and started stabilizing. And the other benefit is that your main transformer supplying the B plus voltage has a couple extra watts of reserve, of magnetic reserve, that it doesn't need to supply the filaments. You have that much energy more left for your B plus voltage. So that's my suggestion for a Heathkit rebuild for using the 802 tubes, 807 tubes as power tubes as application, and going in the approximately 500 volt to 550 volt range. I have not changed it here, but this should be 475 to 550 DC. Thank you, team, and Ivan, happy amplifier building. Have a wonderful day. Bye bye.